This is an interesting time speed distance problem, which says Sumesh traveled from his house to office at 30 kilometers per hour. Then he was late to his office by 5 minutes. So if he's traveling by 30 kilometers per hour, he is late by 5 minutes, 5 minutes compared to his usual time. And if he increases his speed by 10 kilometers per hour, he would be early by 15 minutes to his office. So if he is increasing by 30, I mean, he is increasing 30 by 10, so he's going by the speed of 40 kilometers per hour, then he'll be early by 15 minutes compared to the usual time. So we are asked to find what should be his speed so that he reaches his office on time. So what should be his usual speed to get on time? What you realize that first of all this is a time speed distance problem. So the basic relation is time into speed is equals to distance, of course with appropriate units. But the interesting fact here is that we are given two scenarios, and the distance is constant in both of these scenarios because it's the same distance between house and office. It's not changing. So what I can say is this d is constant, this distance is constant. And when you have two product of two things being a constant, then you can utilize the fact that both of them will be inversely proportional to each other. So yeah, we can use that factor in this question. And let's see how to go about this. We are given two scenarios, so I'll make two structures. I'll make the first case when he is 5 minutes late. So compared to usual time, he takes 5 minutes more. And my second scenario, I'll make it over here. He's 15 minutes early. So compared to usual time, he's 15 minutes early. And yeah, so in the first case, the speed is 30 kilometers per hour. And in the second case, he's increasing by 10. So he gets to 40 kilometers per hour. So can I say that the ratio of speed is 30 is to 40, which is nothing but 3 is to 4? In simplified form, this is the ratio. And since the time and speed are inversely proportional, the ratio of time will be the inverse of the ratio of speeds, which is nothing but 4 is to 3. Now something interesting happens. What is the difference between this 4 and 3? What is the gap between these two times? I'll make another column for the gap. The difference between 4 and 3 is 1. But what is the actual difference between the times? Now this is the case when he's 5 minutes late, and this is the case when he is 15 minutes early. So the difference between those two times will be the gap of 20 minutes in between. So there will be a gap of 20. So what I can do is I can scale this ratio. Remember this is a ratio. So I can scale this ratio to make this difference as 20. So I can multiply the whole ratio by 20, and let's see what that gets us to. This 1 becomes a 20, this 4 becomes an 80, and this 3 becomes a 60. So again, yeah, this is again a scaled version of that ratio. But what happens here is the difference here is now is 20 minutes, which is the actual difference of the two scenarios. It's 20 minutes again. So the master stroke is that you can consider these as your actual times in minutes, of course. So in the first case, he takes 80 minutes. In the second case, he takes 60 minutes. So when he's taking 80 minutes, he's 5 minutes late. So if I were to make the case for ideal scenario, let me make it over in the middle. Uh, he would take 5 minutes less than 80, which is 75 minutes. And it is consistent with the other scenario, which is if he's taking 60 minutes, he is early by 15 minutes because 75 minus 60 is 15. So what we have actually found is the ideal time that he is supposed to take. But that's not our ultimate goal. Our ultimate goal is to find the speed, his speed to reach his office on time. So we have found the time required. We want to find the speed. So what is required is to find the distance. The only information we have is that this distance is constant, and you can find that distance using one of the two scenarios. I'll use the other scenario because the time here is a good number. It's 60 minutes, which is easy to convert to hours. This is nothing but 1 hour. 60 minutes is 1 hour. And if you remember properly that the speed here is 40 kilometers per hour. This was in 40 kilometers per hour. So the distance will be 40 kilometers per hour into 1 hour, which is nothing but 40. So I can say that the distance is 40 kilometers. And we are almost done with the problem. We just need to calculate the speed required. So speed will be the 40 kilometers distance divided by the time. Now you need to be careful here. The time required was 75 minutes. And if you want the speed in kilometers per hour, you need to convert this minutes to hours. So what I'll do is I'll multiply it with something in minutes and divide it by hours. And I know 1 hour is 60 minutes. So this is the thing that I need to multiply it with to convert this to kilometers per hour, because the minutes will get cancelled. And I can also see that 60 and 75, 15 goes into both of them. 15 goes 4 times here, and 5 times here, and 5 goes into 48 times. So what I'm left with is just 8 into 4, which is 32. And yeah, I'm left with kilometers per hour. So the speed is 32 kilometers per hour. What I like about the solution is there's no equation making or assuming any variables. It's just simple calculations and use of logic in exploiting the fact that time and speed are inversely proportional.